Okay, hello, welcome everyone. My name is Rafał, Ślósarz, and today I'm gonna tell you something about testing Flutter applications. But before, I have like nice opportunity to say that I'm really thrilled to see like a lot of people here. You know, this is the second slot of the second day. Yesterday we had a quite wild party, so I didn't expect that much crowd, but still, yet I really appreciate it. Thank you very much for that. So before we start, I have to introduce myself a little bit. So it's not working. It's not okay. So I'm a mobile engineer at Allegro and the CTO at Take and Drive. Also, I'm a co-organizer of Flutter Europe and the organizer of the Poznań Flutter Developer Group. So that will be it of boring stuff, so let's go back to the business. The agenda for today, as you can see, is not very surprising, as we are going to talk about tests. So we will cover unit tests, widget tests, and integration tests, and for this sake, this presentation will be quite basic. But the thing is that I would really like to show you maybe not exactly how the unit test works, because pretty much all of us tasted it. So the reason for this presentation would be like to give you some nice tool set of not a lot of things to use, but maybe those most important in my opinion that makes testing very, very easy. And also I'd like to show you something of how those tests works under the hood. As pretty much all the, in many cases we are not taking enough maybe care of how the code actually works, so we don't understand it, and then we can have some problems. Also I made a simple application, very simple application. It's like really simple application, but that's basics, so we can you can see what's inside. You can check the QR code. If you don't have a laptop, you can check it later, no problem. Okay, so let's start with this question that I would like to settle here. How to make testing easy, but makes those tests that easy that you can actually write those tests before you write your production code. Why so? Because this is actually quite fun when you're using TDD, test-driven development, as when you can get like the Jira ticket, for example, you can simply write the code that exactly describes what's inside, and then you can write your code. But as we all know, it doesn't actually work like this, because usually between those writing this failing test and writing the code that fulfills this test, there is like a lot of frustration and trying to find an answer why the code is not working. Because I have like nice production code that I would really like to have in my application, but the test is not working. So in fact, we are actually doing something like reversed the test-driven development, and we are trying to make our tests passing or making our production code passing the test, and it's not working anyway. Basically, I wrote a book about it, even. So yeah, we can see it on Relay. You can buy it; it's quite cheap from our partners. You can get like the discount. Okay, but I told you a little bit about myself. But I would like to also see what's your opinion, because we are here as a community. So maybe it's not that bad to make a little survey. So please raise your hand, and if you in last 2019 year tested all your commercial Flutter projects. Like no one. Yeah, that means a lot about our community. Yeah. What? Yeah. So actually, it's like can we go now? Like, what's the point? Okay, please raise your hand if you tested any. Okay, any. Still not many. Okay, great. Well, I didn't expect that, honestly. But well, it tells a little bit about the community as well, because before I start with next topic, I really like to see what the community, like the best brains, have to say about. I'm looking at you. Have to say about some topic. So how to make testing easy. So I went to the internet last week and I found this from a Slack. I'm not sure if you see this, but this is Norbert Koss here. Did you raise your hand actually? For any test, yeah. So sometimes, yeah. This is our community, ladies and gentlemen. Okay, that was a few jokes. Let's get back to the business. So the testing environment, how it works. So this is the simplest unit test that you will ever see. Like this is we have imported the package, we have the main function and a test function inside. So pretty much this is the first thing that's nice to notice. It's totally different from what we have on Android or iOS. We don't have like the class with some annotations describing what our tests are. We have a Dart application that is testing our application. This is pretty much what it is. We have the main function, which is like the entry point, and then we have test functions that are registering some callbacks in which we will have our tests. So maybe it's wise to see what's inside this test function. And inside this test function, we are using class called declarer. This body thing is exactly the argument passed as our callback. So as you can see, it's wrapped with a class called invoker. And we can set it aside, actually. This is a very simple helper application that is maintaining the life cycle of a test. But for the sake of this presentation, it's not very important. So our callback is wrapped with some invoker, and then it's run with a function called runZoned. And please raise your hand if you know what this function does. More people than the people who are writing tests? Good. So basically, I feel obligated to tell you a little bit about zones itself. So zones are the objects that, by the definition, they are the objects that are representing dynamic range or extent of asynchronous call. It's quite academic, so I will simplify it a little bit. And less technically, it's just like the object that groups tasks associated with asynchronous call. And it preserves the context for this asynchronous call and makes this context disposable. Less academic, but still not very intuitive. So taking it simplifying it to the bone, we can say that simplifying it really, but still it's like we can think that it's some kind of a object that lets us have this kind of a security that whatever we will run inside of this object, it will probably not interfere with anything from other zone. So if it crashes, no problem. If we will probably try to use some different thread, no thread collisions. So simplifying it to simple object, it's something like a box in which we can place our code and see what happens. If it crashes, okay, we can throw it away. If it's fine, no problem. And this makes zones a perfect tool for testing, but basically zones are the normal thing that our Dart applications are working on. But thanks to this feature that I've described, tests like this, when we have asynchronous callback for a test, and inside we have we are waiting for a future, is working just out of the box. So testing asynchronous operations that are following Flutter rules is not a problem at all. As I said, whenever you run a main function in Dart, the object zone root is created. Never mind if it's like a normal Flutter application or application that will test your application. That's pretty much it. And the zone's responsibility is to create some simulated environment for the tests. Because zones can override some methods like print, schedule microtask, and so on. And basically, we really need this because our tests, especially unit tests, will not run on a physical device. So we don't have all the implementations of all the methods, for example, from Dart UI package. So we would like to have this, emulated for us. So this is something that we can simplify to Roboelectric. This is far-going simplification, but maybe it will stay with you. But this Roboelectric thing actually works, and it's not that difficult to use, and it's not making your tests a nightmare. Also, the zone's responsibility, the code that is run inside of the zone, will be to report some tests, test results, and also catch errors and exceptions from those tests. So now we would like to run our callback that we scheduled with this runZoned operation that I've shown you before. And for this sake, as we run the runZoned code, another zone is created, zone current. And inside of the zone, our callback will be performed. And this will give us a stable environment for asynchronous calls. So our tests, it's possible, but it's not very, following some rules, it's really hard to get the situation well known for Android developers testing applications with RxJava, for example, that the order of tests will affect the results, because we will possibly not clean from before tests, after tests, and some artifacts will stay in our threads. Also, for the last thing, I have to say that we are not limited to the only one zone for the zone current. We can actually create our own zones as well. For example, to store some code to test like some more advanced things like asynchronous protocols. That's not a problem. Okay. So now I'd like to show you the application that I've created. It's very, very simple. It's here. And basically, the idea is that you can type some name of a place, and possibly you will get, it works. So you can see that there is a place, and whenever I click on it, you see there's a hero. So it's not that simple, and it shows you the weather. The application's name is a radar, but because basically at the very beginning I thought I will be showing you the air quality parameters, but this API was paid, so I ended with weather. But still, it works. And what I really wanted to emphasize is that I used block without any package to show you how the testing with rx works, as it's probably the most complicated thing for unit tests. And the thing that is like to emphasize is that we are this is the code of a block for the places, and we are using debounds here. So whenever a user types some input, we're not immediately calling the network call, using the network call, but we are waiting until user somehow ends to type in things. Okay. So now let's talk about unit tests. And as probably we all know what unit tests are, that they should be like small. They should test some small pieces of our code. They're mostly for business logic and so on. I would really like to show you like the three main features that I think are very fundamental for unit tests. And in my opinion, knowing those tools, it's possibly no issue with testing at all. So you can actually start writing unit tests before you actually write your production code, and possibly not have this issue with like being surprised that your production code works somewhat different and tests are not fulfilling their desire. So first thing is I would like to show you the idea of grouping tests and setup and teardown methods. Also set up all and tear down all methods that you're using, and those methods are also not called by some runner or anything else. They are strictly called by the same function that we used before for like the function test. So here are we see that invoker current is invoking teardown methods, and we can see that those teardown methods are called outside of the zone that the code the code of our test is performed. This is actually quite nice to know that usually this gives us the hint that teardown method probably should be used to change some properties from this upper zone, not maybe like exactly the test that we have inside. And also this run setups line means that we are running all the setup methods that we registered for the group or the upper groups as well. Okay, so what I really like about testing Flutter like the most is matchers. Maybe that's simple, but basically speaking, the package, the testing package, provides us with a very nice and an extended setup of matchers. And those matchers are not only for like simple comparing some scalars or something like this, but also thanks to the fact that Dart supports streams natively, we get a really nice setup of stream matchers as well, which allows us to test to check if some elements appeared in the stream in the correct order or never came to happen, or and so on. And this is pretty much fun thing, as honestly speaking, you would probably never had to write any matcher working on a very primitive types. Also, second thing is that testing unit tests for Flutter support Mockito, and this is pretty much the only dependency that you would probably need. Testing with Mockito is somehow different from what we know from Android, as we are creating an object that extends and implements the mock interface, and then we can use it as inside of our tests. It's pretty much a different approach, but still quite valid. In my opinion, it's better because it lets us to have like those mock, like the deep step mocks a little bit easier than we are doing it on Android. But still, this is quite disputable. But nevertheless, Mockito works without any problems. And last thing, but maybe not not least, definitely, testing asynchronous calls. As we said, this test will work just out of the box without any problems. And that's thanks to the fact that we can register asynchronous call as our test. And also, if we are using like normal await, that are following the rules of Flutter, that's pretty much everything that we need. The test will wait for the next result, and everything will work just fine. But we can have some problems, and this is widely spread, that using Eric's dot might be a little bit tricky. Because the test that we have on the left side, when we are just adding some query to our stream, as you can see on the right side, that basically means we are creating our output stream from the query stream, then we are distincting it, and then we have this debounce. So basically speaking, this test would probably hang out, the test of this invocation will just throw in timeout because we didn't registered for our listener for this call. But there are pretty much a lot of different cases we can actually get, and using Eric's dot probably we will get the case where the code will just skip to the next line, and he will perform the except line where we didn't get anything. We didn't have the time. So I've seen pretty much a lot of workarounds for that. People are using some await future for like 1 milliseconds, for example. But the solution is very simple, and we can use like what the dot gives us just out of the box, and that's the schedule microtask function. And the schedule microtask function is quite fun, as basically from the definition, callbacks that are registered through this function are always executed in order and are guaranteed to run before other asynchronous events. So basically, to make it a little bit more understandable, it's something like scheduler.trampoline for Eric's Java. I'm not sure if you're familiar with it. But basically speaking, it will mean that despite the fact that block query add is synchronous operation, there might be plenty of different operations performed later. So this is like this dynamic extent that we described with this by zone. So here, we don't have the possibility to write some await function that will just wait for the query and all the things to perform. So whenever we wrap it inside of the schedule microtask, all the operations that are caused by this block add query will schedule themselves line after line, and then after all those things will be performed, we can go to the next line, which is accept. Basically speaking, this code will mean that we will add something to the query, and then we have this required time to register our callback, register our listener in our accept method. And that's pretty much it, and it solves a lot of problems. So now I would like to show you some live coding. And actually, I'm not sure if we have, we have plenty of time. Great, I'm on time. First time in my life. So so we will write some unit tests, but still, I don't think it's like the necessity to show you like a lot of. To show you tons of different approaches for the unit tests. So first of all, I would like you to. I would like to write a unit test for the block. For places, and I would like to check if whenever I type some query, it will show us the loading page, the loading state, and then it will show us some results. So first of all, it's not like this is just. I would like to explain how my code works. What's the idea behind it? And whenever I write applications, I really like test-driven development. So I usually have like mock repositories inside of my code. I use flavors for that, but for the sake of that simple application, that was not very important. But Okay, sorry for that. So I have this place repository interface that will get us our suggestions. And of course, we have our implementation from the API. It's also very simple. Well, it's not this. It's also very simple, where we have this HTTP call to some URL and so on. But also, it's fun to have, in my opinion, it's nice to have some mock responses that we can do two things. We can either just parse the whole JSON, or we can type it by ourselves. But in fact, we have like one source of truth, and we can use it not only for tests but also. Okay, sorry. But we also can use it for some demonstrations to a customer, and yet we can create like the mock repository that is using those test data. Okay, so having said that, we can write our first test. So we will write the test that will check if it emits loading state and then suggestions. And our suggestions. Okay, so this is the test callback here. Sorry, I have to. Yeah, I see it. Thanks. Sorry, I don't have like the best view from here, honestly speaking. Sorry. Like here is a better view, I think. Okay, so now it works. So we can have like the final suggestions taken from mock response with our play suggestions, and that'll be it. Then we can use our Mockito, which you can see above that we already have this local mock play service. So we use like when API play suggestions with some query, then answers then on sorry final and when then answers. We don't need that. Awesome. Sorry. We can get suggestions. Okay, so that'll be it. And now we can run our block query, and we can add some query string. So now what we probably expect is our block suggestions, play suggestions to emit in order the bunch of different streams. Play suggestion state. And the first state will be loading, and the second with suggestions. With play suggestions equals to what we actually passed. And this test, actually, the thing is that it won't work. We will get the timeout for this test. Okay, sorry. And this first test will just hang, and we'll get the timeout for it. And the reason for that is because, as we said before, we didn't get this block time to actually register the callback. So what we can do right now is to use the schedule microtask, as we said before, and this actually solves a problem, as this test will now run without any problems, as it gave us time to perform these operations in line. So yeah, that'll be it. And now we can go to widget tests, which in my opinion are very nice things to know and to use, because their idea, like unit tests are like unit tests everywhere, but the widget tests are something quite unique for Flutter, definitely distincting it from what we have in Android. And unit tests, widget tests, lets us to create the widget in an emulated environment, and we don't have to run it on a physical device. We can just run it on our thread, and in the same environment as unit tests, actually. And using those two simple tools like Widget Tester and Finder, we can emulate or simulate the interaction between widget and user and widget and the screen. So Widget Tester will basically let us to perform some actions on the widget, and the Finder would let us to find something on predict what widget would like to place on the screen. But this thing is actually a little bit more complicated, as our normal Flutter applications will handle and manage their state by themselves. But in this situation, we would really like to have full control over over how our widgets are recreated. So first of all, we can use the pump widget function, which creates the widget from not existing state to existing state. We have also function pump that recreates the state. So this is pretty much what would be caused by the set state in our widget in the production code. And also we have a nice and funny function called pump and settle, which will repeatedly call pump function until there is no scheduled frames. This is nice, and it works fun when we like to wait until all the transitions ended to see what's on the final screen. But the thing is that we also have to be aware that if we have some pending animations on our screen, like some indicators or anything like this, it will basically mean that our test will just hang and wait forever. So this is a limitation of using this function. And what I would like to also say is that with widget tests we can encourage a lot of problems when it comes to using existing widgets that already have some business logic inside. And a nice example of it is like the image widget with Network Builder. And this widget, what this widget does is it takes the URL and tries to display the image taken from the network. We really want to avoid using network calls in our tests. That's why in testing environment, the zone that we are running it will just prevent this from happening. And whenever we are calling HTTP call, it will just throw HTTP 400 error code. So our test will not work, despite the fact that everything is fine. So what we can do here, we can either use this reverse test-driven development and just decide not to use this image, despite the fact that it's nice and cozy, or we can use the feature of a zone and rewrite or override the behavior of this HTTP call, and decide that whenever we have HTTP call for a given URL, for example, we would like to send a different type of response. like mocked type of the response. We can do this like ourselves, but what I really like to say here is that, honestly speaking, there's a lot of nice packages that are covering this stuff. Of course, we don't have to take the whole package ourselves. It's open source, so we can like copy this solution as well. But still, pretty much all this stuff will be we are able to override those problems using some packages that will let us provide some wrappers outside of our tests. And that's exactly what I would like to show you here. And yep. So the thing is that we are inside of this inside of this test, that the weather screen test that we had here, we are fetching this image from the internet, and basically speaking, this package that I told you about is exactly this one here. And we can run this test with no problem, and it will definitely work. Okay. Okay, so the test passed. Actually, I didn't want to test this here, but okay, never mind. It worked. But whatever, if we will just take this thing out, as I said, we will encourage the problem that we had before, which is this HTTP error code displayed. So we have this exception caught by image resource service. The following network, we got the HTTP 40, despite the fact that our code was just fine. Okay, so I would like to show. I would like to also show you how those testers and finders work. And I think a better idea is to show it here in the environment. As the tester is the object that we are getting as an argument to our callback. So that's the first difference between unit tests and widget tests. We're also using a different function here to get this callback properly. And the tester has many functions that makes testing a little bit easier than it usually is when it comes to UI tests. So it gives us like nice and handy set of functions. For example, we can just type enter text, and this function here will basically do everything for us, from clicking on the clicking on the widget and not only clicking on the widget, but also entering some input via soft key. There are also methods for dragging and for dragging some scroll get gestures and so on, and they're all given us for free. But it might be actually quite interesting for us if you have some more complicated widgets created by yourselves. It's not a problem to create the function as you need, as you wish, using this test as synchronous util provided by the package. And also when it comes to Finder, it lets us to find widgets by type, by key, by some resources, by whatever probably will be inside of this thing. So it works pretty much the same as we know from, for example, Espresso on UI, but as well it's a little bit easier to find, and the API is a little bit more combined. Okay, let's go to the integration tests, as we are running a little bit out of time. And integration tests in Flutter are a little bit different from what we know from Android. Basically speaking, they're running on the same application that we will probably give to our customers, but the only difference is that they also support input from Flutter driver. And the Flutter driver is the tool, and nice tool to write some scripts that will interact with our application on both sides. So either scripts and Flutter driver will enable us to emulate some actions on the screen, but also it will let us to read the content of a screen as well. To use those tests, we just need to create another main an entry point for our application where we are running it. But also here we will have to import the package for the driver extensions and enable the input for our application. And that's pretty much it. After this, we just can create our first integration test where we are creating the Flutter driver entity, connecting it to our device, and then we can interact with it without any bigger problems. But the thing that I like to show you here is that it's not giving us anything for free like this widget test before. As whenever we would like to enter some text to our input, for example, we just have to find it first, and then having this like we have to first click on this thing like manually. We have to call this function, and then we can use the soft key to enter some text. It's not combined as it is with UI test, as it would be quite difficult to emulate everything just as out of the hand. Okay, so the thing that I would like to say about integration tests is that they would usually be written like we will probably cover like those critical paths heading from one side of the application to the other side application, and we would like to test that everything works fine and it works not only smooth, but if there is no like important problems. But the unit integration tests in Flutter are also extremely useful when it comes to tracking key performance indicators. That's pretty much what Philip Project said about during his presentation yesterday. Using integration tests, we can track if we have any junks in our code. It's pretty much simple because we can wrap our integration tests easily with this function from driver, which is trace asynchronous function, which gives us just a timeline, which is a full information about how this performance went. We get inside of this file, we get nice JSON, which tells us what was the we get those flame charts basically. We can see in the browser as well. But from this summary, we can actually easily calculate what was the worst frame build time, for example, or what was the average build time of our frames. And having tests like this, we can easily create some expect methods that will crash whenever we will cross the border, and we will not meet our customers' key performance indicators. So I would also like to show you how those tests work, at this time without me, and it's so basically speaking, we can run those tests from our console. Running the method called Flutter drive, and then we are adding we have to pass the target, which is the name of the file where we created this entry point, and then Flutter driver will run the script from file named the same as our file with the entry point, followed by test suffix. So if we run this command, it will build the application, install it on the app, and run this test. Okay, so we see that all tests passed, and I would like to show you this test file. It's quite simple, as you can see. We are just tapping on the input field. Then we are typing in the query, waiting until there is no other callbacks, and we're checking if everything is in place. Everything is wrapped up with this test trace action function, and those are those expects that I told you about. So we can see if we'll have like a customer that has a lot of different idea on the performance, and we can see that this test will actually fail. So that will be probably quite useful to see it in our CI/CD before we release it to the production or other stages. of our development cycle. Yep. So the test failed, and we get an error message saying that it's a little bit up. Okay, it failed. Okay, it's here. So we get the critical path failure, and we got the information that it's here. Yep. So we have this expected value is different from what we actually get. Yep. So that's it. I think that we can cover those integration tests. Close talking about integration tests, and we can go to summary. So first of all, I would like to say that I think that Flutter is really easy to use framework, and it's actually exactly the same with testing. And because the Flutter is very easy, and the architecture of Flutter is very easy, then it's rather relatively easier than on Android, for example, to start with TDD without any other problems or issues. Also, tests are executing quite fast, as we can see, and we can get a really high coverage of our code because we can also test our widgets in a very effective manner, not like it was on Android, for example, where testing activities or fragments or any other components that were strictly created by the system itself was quite difficult and required additional tools like for Roboelectric, for example. Also, I think that the biggest advantage is having something like widget tests and the fact that asynchronous operations are performed in an easy way and don't require additional tools like, for example, idling resources on anything else. The problem is probably that we have to, with integration tests, there are still some maybe not issues, but it definitely requires some additional work and adding some test code to our production code. Definitely some keys would be useful, as tapping on some, using that driver, tapping on some elements that are embedded quite deep inside would possibly cause some issues and will not let us to perform the test in a proper way. And also those integration tests are not in that stage that Android UI tests are, where we have, for example, Android Orchestrator that lets us perform those tests in an effective parallel way. Okay, so that'll be it. Thank you very much for your attention. So I think we have time for maybe 1 or 2 questions. Maybe any?
First of all, thank you for your good presentation, and I would like.
Well, I can hear you actually.
Thank you for the good presentation, and I would like to ask one question. In case if we have an application written on Flutter, and then this application uses some kind of web views, OS interactions, how can we test it?
Can you repeat, please, because I didn't hear it.
In case if the application have some interactions with the web use and OS interactions like Wi-Fi on states, Bluetooth, and so on, how can we test it?
As far as I understand your question, you're asking how can we test the code that is written natively in our application, like this native part of our Flutter application. Yep. Well, basically speaking, we are using exactly the same environment for Android tests or iOS tests. We have those tests inside because Flutter application creates, like when you create like a new Flutter application in Android Studio, you also get for free like the first activity and first UI controller from your iOS and Android. So you can test this code exactly the same as you will do this on Android and iOS. Okay, so thank you very much. If there's no other questions.